There was another formula that I used in my class last year. If y'all remember, A equals PERT. Does that sound familiar?
Oh, yeah.
A equals PERT, P times E to the power of RT. They mean the exact same thing, all right? But I'm gonna stick with the original that was already posted on here. Exponential growth is gonna happen when the K value is positive. Then what can we say about the K value if it's a decay? It is negative. Just to refresh, listen up, because I'm not writing all the pieces on the side like I did last year. C is the original amount at the beginning. Y is the end result that we want. T is a time in years, and K is going to be the rate. All right? So there's a shortcut to finding the K that I'm going to share with you at the very end of number 1. Because some of you guys might not remember the formula right off the bat, and you want it traditionally. For that matter, let's wait on for that.
It's Y again.
What's that?
What's Y again?
Y is the end result. Okay? Andrew, read number 1.
Suppose that 10 grams of the plutonium isotope Pu-239 were released in the Chernobyl nuclear accident. How long will it take for the 10 grams to decay into 1 gram? The half-life of Pu-239 is 24,360 years.
All right. To actually start this problem and answer the question, the first thing we need to find is what is a K value? And that K value is going to be helped with the year of 24,360. So our step 1 is I want half-life. If I'm starting with 10 and I want that to become half of it, how many is that? 5. And the original is 10. Then I have e to the power of. K is what we are looking for. Our time is 24,360. And you'll need your calculator for this one, so grab one if you have a class set. If you have your own, get them out as well. Because at some point we're storing the number because it's very, very small in decimal. So you'll have to type it in.
What is K?
K is the rate. The rate. All right, let's divide it by 10 on both sides. We get 1 over 2 is equal to e to the power of that. So now, my variable is not e. E is a number. Where is my variable k located? In the exponent. So here's what we need to do on both sides. I need to take the natural log on both sides. Because the natural log of e cancels out. And that's going to give us natural log of 1/2 is equal to k now drops down with 24,360. So now, to solve for the k, I just need to divide it by that time. And here's where the calculator comes into play. Let's type in natural log of 0.5. It's a clean number, so I think 0.5 is doable. And on the bottom, we have 24,360. Oh, 360. And here's what I have. If you're just watching and not typing, that's going to be a problem on the day of the test. Now, it's going to give us very, very small number. Let's see what that actually means on paper. That E means our decimal is going to be moved to the left 5 times. So ideally, what this actually looks like is negative 0.000028. And because I don't want to memorize this number, nor am I going to round it, we are going to store this number as K. If y'all remember storing last year, do y'all see the stow button right here? Stow, next to the 1? Click on that. And you only click on that once you have your answer on the previous column or row. And we're going to store as alpha K. You can put in any letter you want, but let's be consistent with the formula. So help your neighbor. So first type in the fractional value and store it as K. So anytime I use a variable K, it's going to be a number from now on. All right, so my second step is answering the actual question. 10 gram decay to 1 gram. So we're going to eventually get to 1 gram from 10. E to the power of, K is a number, T. And let's divide it by 10 on both sides. 1 over 10 is equal to e to the power of KT. Now keep in mind, E is a number, K is a number. My variable, again, is where? It's on the exponent, so natural log on both sides. So I have my K is equal to, that goes away. KT is equal to natural log of 1/10. Now I could find the T value by dividing by the K. Let's type that in. Got natural log. 1/10 is 0.1, so I'm gonna stick with that one. K. So here's what I have. So let's kind of do a little approximation. If 10 go into 5, it's going to take 24,000 years. 10 go into 1, it's going to take a lot longer. Is that true? So we're anticipating it to be way over 24. Is that true? Yeah, the number does make sense. I don't know who's going to live that long to keep up with this, but you know. I want to make it into whole numbers just because. But if this were to be on your assessment, it'll tell you exactly how to round. Is everyone good with that?
Yes, ma'am.
That is strictly reminder from pre-cal, all right? Some of them from algebra 2. Yes, ma'am?
Where's natural log on the calculator?
It is right next to the 4, to the left of it. You see it? Go to number 4 and look to the left of that. So here's a shortcut to find the K. Let's say you don't want to do all of this, and you're like, you know what, let's do a shortcut. It is always going to be the natural log of the factor over the time. And that's going to give you the K value at all times. But if you forget this, take it traditionally, okay? And we'll apply this on number 2. All right, Gianta, let's read number 2.
Suppose you make the initial investment of $10,000 into an account where interest is compounded continuously. In 5 years, the amount of money in your account has doubled. What is your annual rate of return? How much money will you have in 10 years?
So we want to find what is our annual rate in return, that's step 1. And then in 10 years, how much are we going to make as our step 2? So we're starting with $10,000, and I want that to double. What is that amount? 20,000 is equal to 10,000 times e to the power of, and we know that in years is 5 years, and k is the variable we want. So when I divide it by 10,000, that's going to give us, or actually let's apply the rule. K is natural log of the factor. From 10 to 20,000, isn't that a factor of 2? And how many years is that in a span of? 5. So if you want to do all that work, go for it. If you want to go ahead and use that trick, that's also okay. Let's type that in. So we have natural log of 2 over 5. And let's write this out to 3 decimal places. But we are going to do what to that number? Store it. So let's go to stow as our k value, and voila. So now anytime I use the k value, that's my new decimal. Cody, are you going to write it all?
Yeah.
Okay. Now let's go on to our step 2. Our step 2 says, how much will you have? So we don't know what that y value is at the moment, but we do know we started with $10,000. E to the power of, k is a number. In how many years it says? 10. Now let's see where the variable is. Is my variable on the left or the right at the moment? It's on the left. That means everything on the right is a number. All we have to do is type it in. Very nice, huh? If you do second natural log, it'll bring up the e value. We got k times 10. So here's what I have. So Milo, how many is it? Since you're computing it in your head. You're like, no. It's going to be $40,000. Is that our like college tuition? A year or 2?
Like
I don't
a
know.
year.
A year. That's so sad. All right. Are we all set? Okay, let's go on to number 3 and let's do more practice with e to the power of whatever. When we are solving for a differential equation, the first thing that you should do is rewrite the y prime as dy over dx. So we have 5xy plus dy over dx is equal to 50x. This is more like algebra practice. Since I need to make dy over dx by itself, let's move the 5xy. So dy over dx is equal to 50x minus 5xy. What is common on the right side of the equation that I could factor out? 5x. So dy over dx is equal to, and I'm going to put 5x in parentheses, just because. That's going to give us, is that 10 minus y? So now let's put all the y's together and x's together. So I need to move the 10 minus y by dividing. I need to move the dx by multiplying. So I get dy over 10 minus y is equal to 5x dx. Now what do we do on both sides? We integrate. And when we do for the first one, that's going to be our u substitution. So let's write u is equal to 10 minus the y, which is du. Oh, that doesn't look like a u. Du is negative dy. And when I compare, does that dy have a negative with it? Move it over. So let's rewrite. I'm going to go ahead and throw out the negative over. 1 over u du. That's going to give us negative natural log of the absolute value of u, which then is negative of the natural log of 10 minus y. That was just the left side. Equal to. Let's do this one. We have 5 over. With the understood 1, what is 1 more? 2. X squared plus c. And since we're solving for y, I know I'm going to do the e to all of that power, but what is in front of the natural log that I need to get rid of? The negative. So let's go ahead and give a negative to the other side. So when I rewrite, we get natural log of the 10 minus the y is equal to negative 5 over 2 x squared. If you want to write minus c, go for it. I'm going to write plus c, because if c in itself can be a negative, whether you write a plus c or minus c, doesn't matter. Okay? So now, how can I get rid of our natural log? E to all of that power. So we know that's going to go away. What else is going to go away since the natural log is gone? The absolute value. 10 minus a y is equal to, and the way I'm going to write out is e to the power of c is already c. And that's what we talked about on the previous one. And let's leave the remaining power as it is. And then I'm going to solve for y. To solve for y, don't I need to pretty much move the y to the right side and move everything on the right to the left? Okay? So if you're comfortable taking 2 steps, go for it. So I have 10 minus c times that power. Now, something unique that could happen on the AP test. What did I say about the sign in front of the c? Does it have to be a minus? Can it be a plus in case c in itself could be a negative? So another form you could see, but it won't show up at the same time, is 10 plus c times e to that power. And they mean the exact same thing. Because c could be positive, or c alone could be negative. So let's go on to number 4, and that's our last one. And I'm going to help you on number 12 on the homework. Okay, Cody, let's read number 4, please.
In many applications, the rate of change of a variable y is proportional to the value of y. If is a function of time t, then the proportionality can be written as dy over dt equals ky. Solve for long-term t.
So on this one, all I see is variables, right? We don't like it. So here's what I'm going to do. I'm going to alter this problem where it's going to be easier for you to understand, and we're going to plug it back in, all right? So what that means is, instead of our k value, I'm gonna actually put in a random k number. So let's write out dy over dt is equal to, just gonna pick out 2, you could pick 3, 4, whatever you want. And then I wanna go ahead and put the y's together and t's together with the constant. So I'm gonna get 1 over y, dy, and yes, you could put the dy on the top, is equal to 2 dt. And we want to solve for a y, so let's integrate. When I integrate 1 over y, isn't that the natural log? Do I hear a yes?
Yes.
All right. What is the integration of 2? 2t. And that one's in terms of t. I know we typically use our x's. And let's put plus c. Since I'm solving for y, I need to get rid of the natural log. What do I need to make this all to the power of? E to the power of. So we know that's going to go away. And the absolute value will go away as well. Right, Xavier? Keep writing. And e to the power of c is already c. And then I have, actually I'm just going to rewrite the whole thing. 2t plus c. Which then we'll get y is equal to c e to the 2t. Since I was kind of borrowing the 2 instead of k, let's put it back in terms of the k. Y is equal to c e to the power of kt. Isn't that the formula we were using the whole time on this lesson?
Yes.
Interesting.